Are you ready to journey to the edge of the universe and unlock one of the most mysterious phenomena in space? Get ready to buckle up and join us as we explore the mind-bending world of gamma-ray bursts, the most powerful explosions in the universe. With its intense bursts of radiation and unpredictable behavior, this cosmic puzzle has left scientists scratching their heads for decades. But with new technology and cutting-edge research, we may finally be on the brink of unraveling its secrets. So, don't miss out on this epic adventure and hit that play button now. What are gamma-ray bursts? Gamma-ray bursts, GRBs, are short-lived bursts of gamma-ray light, the most energetic form of light. Lasting anywhere from a few milliseconds to several minutes, GRBs shine hundreds of times brighter than a typical supernova and about 1,000,000 trillion times as bright as the sun. When a GRB erupts, it is briefly the brightest source of cosmic gamma-ray photons in the observable universe. Until recently, GRBs were arguably the biggest mystery in high-energy astronomy. They were discovered serendipitously in the late 1960s by U.S. military satellites which were on the lookout for Soviet nuclear testing in violation of the Atmospheric Nuclear Test Ban Treaty. These satellites carried gamma-ray detectors since a nuclear explosion produces gamma rays. They didn't find any violations of the nuclear treaty, but they did discover bright bursts of gamma rays from beyond the solar system. Evidence from recent satellites like Swift and Fermi indicates that the energy behind a gamma-ray burst comes from the collapse of matter into a black hole. Two types of GRBs. When astronomers looked at the number of bursts versus how long they lasted, they found two different classes of bursts: long duration and short duration. These two classes are likely created by different processes, but the result in both cases is a brand new black hole. Long-duration bursts last anywhere from 2 seconds to a few hundred seconds, several minutes, with an average time of about 30 seconds. They are associated with the deaths of massive stars in supernovas, though not every supernova produces a gamma-ray burst. Short-duration bursts are those that last less than 2 seconds, lasting anywhere from a few milliseconds to 2 seconds, with an average duration of about 0.3 seconds, or 300 milliseconds. These bursts appear to be associated with the merger of two neutron stars into a new black hole, or a neutron star with a black hole to form a larger black hole. First ever discovery. Very brief flashes of energetic gamma rays from space were discovered in the late 1960s. It took 30 years for astronomers to discover that they originated in extremely remote galaxies. Gamma-ray bursts are associated with the most powerful explosions in the universe, produced by colliding neutron stars or by the collapse of giant stars into black holes. Luckily, their energy is strongly beamed. Only if one went off in our part of the Milky Way galaxy, and if the Earth were in the path of the narrow beam, would one half of our planet be sterilized immediately by the deadly radiation. Gamma-ray bursts are observed all over the sky at a rate of about 1 per day. Their true number is probably much larger. Gamma rays, along with less energetic radiation at longer wavelengths, are produced when matter from a cosmic explosion is ejected at nearly light speed and then slams into interstellar material. Classification. The light curves of gamma-ray bursts are extremely diverse and complex. No two gamma-ray burst light curves are identical, with large variation observed in almost every property. The duration of observable emission can vary from milliseconds to tens of minutes. There can be a single peak or several individual sepulses, and individual peaks can be symmetric, or with fast brightening and very slow fading. Some bursts are preceded by a precursor event, a weak burst that is then followed, after seconds to minutes of no emission at all, by the much more intense, true bursting episode. The light curves of some events have extremely chaotic and complicated profiles with almost no discernible patterns. What are the causes of gamma-ray bursts? Thanks to the growing observational record, just 2 out of the hundreds of theories posited about gamma-ray bursts in the 1970s remain most viable today. Scientists now know that the vast majority of gamma-ray bursts are long bursts, longer than 2 seconds. They are thought to occur when a massive star runs out of fuel. Without a force to resist the crush of its gravity, the core of the star collapses into a black hole. The material falls into the hole at near light speed and bears a tremendous amount of energy. That energy spews into space as 2 jets of gamma rays shoot in opposite directions. Only when a jet is directed toward Earth can instruments detect the burst. The jets also explain why gamma-ray bursts are so intense. The energy is concentrated in just 2 directions and not diluted in all directions. Short-ray bursts are under 2 seconds long. They're very different from long bursts, not just in their duration, but in the objects that create them. They come from different regions of space, places where you don't see stars being formed. Gerels and his colleagues think that short gamma-ray bursts are formed from merging neutron stars. These small, rapidly spinning, late-stage stars are so dense that a teaspoon of their material would tip the scales at 1 billion tons. Neutron stars often pair in binaries, circling one another until their orbits decay. Eventually, they coalesce violently, releasing their energy as a short, explosive gamma-ray burst. What gamma-ray bursts tell us? In astronomy, distance is time. Since it takes light so long to travel across cosmic distances, the gamma-ray bursts that Gerels, Burrows, and Ms. Rose study happened 7, 10, and 13 billion years ago. The burst's light is just now reaching Earth. Therefore, these are one of the few cosmic events that enable scientists to study the early universe. One way gamma-ray bursts do this is by acting as a beacon, a bulb of background light that allows the study of the gas between Earth and the burst source. Analysis of the gas can reveal the chemical elements that were present in the burst's host galaxy in its earliest stages. Because gamma-ray bursts originate from massive stars, they also lend insight into star formation rates in the early universe. Indeed, scientists see the most gamma-ray bursts occurring at distances of around 7 billion light-years, which coincides with the time when most massive stars were formed. Gamma-ray bursts are now being used to study some of the most distant regions that we've ever been able to look at. We hope that in the next few years, we will find a gamma-ray burst that is farther away than anything else we have ever seen. That will allow us to step even a little bit farther into the unknown. In conclusion, mysterious gamma-ray bursts are one of the most fascinating and enigmatic phenomena in the universe. These intense bursts of energy have been baffling scientists for decades, and we still have much to learn about their origins and effects. But with new technologies and innovative research, we're getting closer and closer to unraveling these cosmic mysteries. So, if you're as intrigued by these explosive events as we are, don't forget to hit that subscribe button and stay tuned for more incredible content. Who knows what other secrets the universe has in store for us? Thanks for watching.